Maths Performance Task by Cameron James Wong-Swingham. Hello, my name is Cameron James Wong-Swingham from S208. I'm here to help you solve this challenging maths question. A spider sits at the middle point P of my living room wall. It sees a flying corner C. Find the shortest distance the spider must travel to reach C. Alright, I'll do this on a piece of paper so it's much more easier for you to understand and you can see my workings as well. Alright, so here's the diagram. The sides look a bit curved, but is actually the camera angle. Assuming that the spider cannot fly to point C straight from point P, and that the spider can climb on the ceiling, usually the shortest distance to a certain point is usually just going straight towards it, but it does not look like we can go straight towards it on the ceiling as we cannot see the straight path clearly as we are moving from a vertical wall to a horizontal wall. Now let's assume that if I can fold ADEH with ABCD, then you guys can see it much more clearly. Alright, from the picture we can see the shortest route to C, and we have to find the length from P to C. To do this we have to use the Pythagoras theorem, which is used to find the hypotenuse. It is when you square the sides of the triangle, which are not the hypotenuse, and add them together, and square root them to get the hypotenuse. We will name the midpoint of H and D as X or HD. So the midpoint has two names and it will be written as HD in the workings, but it will be said as X. CP looks like the hypotenuse, so if we square XP and CX, then add them together and find the square root of them, then we have the answer to the distance of P to C, which is also the answer of the shortest distance for the spider to reach point C. So, to find PX, we have to divide 4 meters by 2, which gives Px a length of 2 meters, and xd is 1 meter, as hd is 2 meters, and dx is half of hd. As the Pythagoras theorem goes, a squared plus b squared is equal to c squared. A and b are the sides of the triangle which are not the hypotenuse, and if you square them and add them together and square root them, you get the length of the hypotenuse of the triangle. As you can see from the picture, PC is the hypotenuse of the triangle PXC. So PC will be the C in the Pythagoras theorem, and the other two sides will be A and B. We will let XC be A and PX be B. To find XC, we have to add XD and DC. We found out that XD is 1 meter and that it is given that DC is 5 meters. So we have to add 5 meters with 1 meters, which is 6 meters, which means that XC, also known as A, is 6 meters. We already know that PX is 2 meters and is also B. So we change all the letters in the Pythagoras theorem into numbers now, which is 6 squared added with 2 squared, which is equal to C squared, or P squared, you can say it. So 2 squared added with 6 squared is equal to 40. So 40 is equal to C squared. So if we square root 40, then we will have C, which is the length of Px, and the answer for square rooting 40 is 6.32 when converted to 2 decimals. So Px, which is also the shortest distance for the spider to reach point C, is 6.32 meters. So the question is solved, and the shortest distance for the spider who could travel to reach point C is 6.32 meters, converted into 2 decimal places. Here is just a simpler version of triangle XPC by itself, to let you to be able to understand what was happening inside the triangle much more clearly. Of course, there are many other ways in which the spider could travel to point C. It can move to point D and move along the edge of the room from D to C. Maybe the spider could even crawl down the wall and along the floor to point G, and crawl straight up to reach point C. The spider can also take very long routes and travel from point P to A, then of course to B, and then to C, which sorts of leads the spider to the opposite direction at the start. Thank you for the presentation. Thank you everybody, ladies and gentlemen, see you.